T-distribution is very important when you do not have the population standard deviation. Standard deviation is unknown. We use T-distribution. Statistics for business and economics will remain as the benchmark book, a good book if you want to purchase it. It's readily available around the world. However, we are talking about variables. Now we are talking about random variables. Till now, whatever I've discussed falls under the preview of random variables. I have discussed normal distribution. So when you're talking about normal distribution and not to T-distribution, will come under continuous probability distribution. And I'll just touch upon this topic today. The other topic is discrete probability, which is got binomial and Poisson. Today I'm discussing about hypothesis testing. So second part, now we have discussed when the population standard deviation is known. So we've used standard normal distribution. Today I'm going to be introducing students T-distribution when population standard deviation is unknown. The third part is a small I'll be introducing is population proportion, but that uses again standard normal distribution. When do we use student T-distribution? Suggest you read up on this. There's an accompanying feature which I'm going to be posting, and also there are a lot of data available, a lot of information available online. You can also go through books. When you're talking about T-distribution, they're very similar. This is from the family of probability distribution. You'll be using the sample standard deviation S. So that's one of the difference. And you're using the sample standard deviation to get the interval estimate of population mean, which is what we'll be calculating through T-test. Discussing as you go forward. One of the main criteria now you'll always have to remember is when the population standard deviation is not known, we use T-distribution. Whenever you're talking about T-distribution, the sample size is less, which I talked about. I was talking about T-distribution, we talk about degrees of freedom. T-distribution is very similar to normal distribution. The mean is 0 and the standard deviation is symmetrical about the mean, which we talked about. Its tails are longer and thicker. So that's the difference, and the center part is much shorter as compared to normal distribution. Degrees of freedom are something which is very unique. So for different degrees of freedom, you'll have a different curve. And as the degrees of freedom increases, the T-distribution becomes very similar to normal distribution. Generally, the thumb rule is over 30. So T-distribution can go to infinite degrees of freedom. And as the T-distribution, specifically it's over 30, the T-distribution is very similar to normal distribution. Degrees of freedom is something which I'll again take as a separate topic. So degrees of freedom is a parameter which highlights the independent variables which are involved in calculating the estimate or statistic. Talking about statistic, before I come to statistic, we talk about probability density function, because whenever you're talking about random variables and you looked at this particular diagram, so this is something known as PDF T-distribution. However, I'm talking about PDF, it's a probability density function. These are functions which are used to compute probabilities of continuous random variables. This is very similar to normal distribution when I was talking about the total area under the curve is 1, which is actually for the function of variables x, which is greater or equal to 0. Probability density function for a continuous variable, it gives you the probability estimate over a interval, which is basically between a range of values. So talking about those range of values, it basically take out the area between those 2 points, and which gives you the probability of continuous variable. However, whenever you're taking probability of a single point or a variable, it will always have a 0 probability. So there are n number of permutation combinations for that particular variable, and the interval is 0. Since the length of the interval is 0, the single point of variable will have a 0 probability. I have an accompanying article which talks about why T model or is T model better at explaining outliers than normal model. Now I leave it to you. You see that the tails are much thicker. Refer to that interesting piece of research. T statistic values. The difference is now you have S, and S is basically the sample standard deviation, and you're getting this point estimate from the sample. Here I'm talking about a cumulative distribution function. I'm talking about CDF. You're looking at the probability of a variable which you have seen, which is less than or equal to X on the left hand side. So it gives you the probability on the left hand side when you are looking at T distribution with this function which I have used as CDF. Completely the same thing as we have done before. You have a single tail test and a double tail test. You will be using the null hypothesis and alternative hypothesis. Alternative hypothesis is always the hypothesis which the research is trying to prove. If you're reading the critical values, it is again pretty much very similar. Whenever I talk about T alpha here, you're looking at the values to the right. Whenever I'm looking right, so usually the function gives you the probability on the left. Whenever you're going to be testing, you'll be using getting the probability to the right hand side, that particular level of significance which is given by alpha. Before we go into what sort of Excel functions which you can use. Excel has got quite a few functions for you to solve the numericals. We go by step. The first step, of course, as you know that the population standard deviation is unknown, you'll use t-distribution. You'll do the then same thing. You'll do hypothesis, understand whether it's a single tail test or a double tail test. You'll calculate the critical value through the t statistic, p-value. You will always reject the null. P-value is the smallest value for which you can reject the null. That level of significance, you're going to use that p-value. You're taking t as alpha. You want to take the probability on the right. You have a function here. You can use t, gives you the probability on the right. This is for a single tail test. When you're looking at you want to find the probability on the upper tail. If you want to find the probability on the lower tail, you don't use this function. You also have function on this. Function gives you the probability on the left. And you will be using t.dist.2t. So then you get the value on both ends side. Very good functions to use to find the p-values when you're checking the hypothesis. Doing the hypothesis, we'll still stick to the p-values. We'll always reject the null when p-value is less than or equal to alpha.